Today is day 2 of Unit 5. We're going to continue with absolute value functions. Before we start with today's lesson, I just wanted to go over the homework that I gave you yesterday. So this is page 5, absolute value functions homework. So first you guys had to graph two absolute value functions and explain how they transform, how the g of x transform from f of x. So first we have our regular parent function, we call this. We'll talk about that when we get back from break. Our parent function, which is just the absolute value of x. And then for the next part you had to graph the absolute value of x minus 6. So if you graphed that in your calculator, your tables would look like this, here. And you would notice that this shifted from here 6 units to the right. Okay, so if we subtract inside of the absolute value, it moves our function to the right. The next one, number 2, your graph looks like this, and I know it didn't ask you, but if I were to put the original absolute value of x function, you would see that it merely moves up 3 units. Okay, so when we add on the outside, that moves it up. Okay? Now on the back, this kind of covers the rest of them. For number 3, what equation would move the graph y equals the absolute value of x down 3 units? That would be D. Number 4, which would move the graph y equals absolute value of x to the 3 units to the left, that would be adding 3 inside of the absolute value, and then reflection over the y-axis is just negating that absolute value. And again, if you couldn't look at the rules I gave you yesterday in last unit or last lesson, then throw these in your actual calculators and you will see how they shift. And lastly, I gave you an absolute value question using algebra. So all this is asking is basically to evaluate f of 3 and f of 2 for the function 3 times the absolute value of x minus 3. So what I've done here is I've done all the steps so you can see. Remember notation, f of 3, we substitute a 3 everywhere we see an x, and then we evaluate. Use those absolute values as if they were parentheses. They work exactly the same. Evaluate what's inside, then take the absolute value, then multiply and get your answer. Take what's inside, then take the absolute value, multiply, and that's your answer. And then make sure you actually answer the question. It didn't just want each of those separately, it wanted the difference. So I plugged that all in, and your final answer should be 3. Alright, so for today's lesson, we are trying to figure out what effect does changing the coefficient of an absolute value function have on the graph. So we've talked about shifting it up, down, left, right, and reflection, but we haven't really talked about if we change the number in front of the x, okay, as well as the number outside of the absolute value. Okay, so sorry, this is so blurry. What you're going to do, again, I will refresh your memory of how to put this in your calculator. Okay, so clear everything. So we're going to graph. So again, math, number, absolute value, and we'll put an x in there. Okay, do it again. So we're going to do this 3 times. Okay, now we have a 5 times x, and for our last function we have 0.5, so we have a fraction. Okay, you're going to graph those and you're going to see, so there's your original, there's 5x, and there's 0.5x. So go ahead and look at your table, and you can graph all of these. We put 3, so you're going to have to scroll over 1 to get your third set of y coordinates. The other nice thing about just multiplying is that your vertex, your turning point, is going to stay in the same spot at 0, 0. So let me just show you how I graph these. Okay, so here are the 3 graphs. Try to make that a little less blurry. Okay, here are my 3 graphs. The black one is going to be just your regular 0, 0, 1, 1, 2, 2, etc. So the blue one, that's when we multiply by a number bigger than 1. Okay, if you notice, it kind of squeezes. Okay, what we say is that it gets narrower. All right. If you look at the blue, when we multiplied by 0.5 or a number less than 1, and between 0, so between 0 and 1, this is going to kind of flatten out our absolute value, so it makes it wider. Okay? And of course you can pause the video if you need more time to do that yourself. Alright, so basically what we want to conclude from this is as the coefficient increases, again the coefficient, and I'll actually just write it on here. Okay, so the coefficient, just as a reminder, the number in front of the variable. Okay, so as that number increases, the graph becomes narrower. As the coefficient decreases, the graph gets wider. Okay, so let's look at our next one. Okay, so for the next one, you're going to do the same thing, but now we're looking at if the coefficient is on the outside of your absolute value. Okay, so go ahead and put that in your calculator. So the thing to remember about this one is that 3, let me get my y equal, getting your y equals. Okay, the 3 is outside of the absolute value, so you got to hit that first. Okay, then you hit your math button. Oh my goodness, sorry. Go to your absolute value and hit the x. Okay, so again, you can see, same type deal, it squeezes it. Okay. Alright, so here's what my graph looks like. Okay. Again, I just copied it down off of my calculator and then threw it in my graph. So the next thing we're going to look at is we are going to rewrite for B and C. Again, I wanted to go over the notation. I wanted to show you how the graph moves. Okay. So again, the biggest thing here is I want you guys to understand what the notation is. Okay, remember the notation is just how something is presented to you. Okay. So when we are doing this, you're just going to substitute in what they have. Okay, so f of x comes from up top here. We said f of x is equal to 3 times the absolute value of x. Okay, so when we rewrite this, we're just going to fill that in. So g of x is equal to 3 absolute value of x minus 2. And how is it translated? If you throw that in your calculator, you will see this shifts down to units. So make sure you try that out. Okay, and then now, remember, if we are subtracting something inside the parentheses, we are going to keep that inside of the absolute value. So it's going to look like this. And again, for that, that works the same as if there was no coefficient. So throw that in your calculator and you'll see it shifts, not 2, 4 units to the right. Okay. All right, for the next one, we want to see what happens to the graph if we multiply it by -1/2. So we know that if we multiplied it by 3, it got wider. So now we want to look at if we multiply it by -1/2, what happens to it? Okay. Okay, so put in your parent function. Oh, pressed the wrong button, sorry. Okay, so you're going to put the absolute value of x, and then you are going to put -0.5 or -1/2, whichever, same thing. Absolute value of x. See what that graph looks like. Okay, so that graph is not only going to be wider, but it's also going to reflect over the x-axis. Okay. So that one's a little tricky for the points. Let's look at the table. Okay. Oh, sorry about that. Okay, so we're still going to be at 0, 0. And then alright, it's going to look like that. So f of, what letter do they use? Oh, we'll just do that. Okay, f of x is equal to -1/2 absolute value of x. So it is getting, so it's not narrower, it's wider, it's not downward. So it's going to be wider, and it opens downward. That's a reflection. So now we're going to do a little bit with the range. So what I'm going to need you to do, again, throw this in your calculator. Everything. So we have the absolute value of, okay, math, number, absolute value of x minus 3. Okay, so now we just need to look at the graph. Okay, and we need to answer these questions. So we want to know what is not true. So the first thing it says, I'm just going to do this. The first thing it says is 0 is less than or equal to y. I'm sorry. Yeah, that's right. And so y goes from 0 to infinity. That's what this says right there. So that actually is the range. This is the range. Okay. Also, if you look, number 2 is the range as well. So that is always true because they're the range. All right. If x is greater than 0, if x is less than 0, then f of x is less than 0. Well, y is never less than 0. Y is never less than 0. So that's going to be our answer. Also have to keep going. So if x is greater than 3, then f of x is increasing. That's true. Okay? So number 3 is your answer. All right, so for classwork, I'm going to have you do numbers 8 through 10. Okay, so this whole entire page. So please make sure you read through, okay? You're going to write homework, but you should be able to finish this in class. Numbers 8 through 10. Please let me know if you need help with a range, but try it out on your own as well. All right, we will finish this off with this page. So now we're going to actually write the equation for the translation. All right, so the first one says that it reflects over the x-axis. All right, so we know that reflecting over the x-axis, you just merely negate that absolute value. Okay, that is reflection. Now we're going to go 5 units down. 5 units down means we are going to do this on the outside. So we do our absolute value and subtract 5. Lastly, we're going to do 4 units to the right. So remember, that is inside of your absolute value. To the right would be minus. All right. And please add number 12 to your homework.
Laura Hopkins, if you're in the building, please contact the main office. Laura Hopkins, contact the main office. Thank you.
Sorry for that. Okay, so again, your homework, number 8 through 10 and 12.